Hey guys, Mrs. Bodechon here. So today we're going to look at 1B for our AKS portfolio. It says I can use proton atomic number to identify elements. So first off, if we look at our periodic table, you guys will notice that the atomic number is this top number here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you guys see them? So those represent how many protons are in the nucleus of our atom. Now, an atom is identified by that number. So if I have one proton in the nucleus, it's going to be hydrogen, and it's always going to be hydrogen. It's not going to ever be a different element because that's how we name hydrogen is by looking at how many protons are in the nucleus of an atom. So if there's one, it's hydrogen. Notice these numbers don't repeat because they are unique, and that is how we name them and identify them. So on your paper, you have a sheet that looks like this little chart, and you're asked to fill in the blanks. So let's do a couple together and make sure we really understand this. First one's simple. It's telling us, hey, this is boron, right? The atomic symbol for B is boron, and it has 6 neutrons. So a lot of these on here are going to be isotopes, which means that we're going to have to take into consideration protons plus neutrons gives us an atomic mass, okay? So we're not filling in the atomic mass based off of the decimal point on the periodic table. In this case, we're going to be adding protons plus neutrons to get our mass. So let's go ahead and start filling this out with boron. So if we look at boron is right here. Boron is number 5. So immediately we can go ahead and write number 5 for atomic mass, number 5 for protons. These are all neutral atoms because it doesn't say they're not. So we can automatically assume there are also 5 electrons. Now, like I said, for atomic mass, we are going to be adding up protons plus neutrons. So we said there's 5 protons plus the 6 neutrons, which would give us 11. And you're going to do all of these like this. So let me kind of just show you how I did these so you'll see how it works and you can figure it out. So this one is giving us the atomic number and it's giving us the atomic mass. What's the vital piece of information there? It's definitely the atomic number because that's the number of protons. So immediately I can already write 11 protons. But because this is a neutral atom, I can also go ahead and write 11 electrons, right? Because we have an equal number of protons and electrons in a neutral atom. Now I can go and I can look at my periodic table for number 11 and I can find that that's sodium. So I can go ahead and write Na right here. Now in order to find my neutrons, I have to do my atomic mass minus my protons. So if I do 24 minus 11, I'm going to go ahead and get 12. So I have 12 neutrons in this particular atom. Remember, there are isotopes out there, and if you look on the periodic table, the mass is not going to be the same mass that's on there. This mass says, what, 22 point something, which is not what you're seeing here. This one says 24. This is an isotope of sodium. Remember, an isotope is just the same number of protons, but different number of neutrons, all right? So we clearly have a different number of neutrons, which is just an isotope of sodium, no big deal. All right, our next one, we're given protons and we're given neutrons. Right away, we can go ahead and just add those up to get our mass, right? So we can add up 37 neutrons plus 31 protons and get that mass of 68. Now, if I have 31 protons, I'm also going to have 31 electrons because in a neutral atom, they have to balance. And if I have 31 protons, it means my atomic number is 31, right? That's the top number on the periodic table. So if I go and I look for number 31, I can see that, hey, that's gallium. So it's Ga, and I can go ahead and write that symbol down. And that's how you're going to do this with all of these, you guys. So if you look, the next one, we have atomic mass and we have electrons. Well, if my electrons are 39, it means my protons are 39 because in a neutral atom, those have to be equal positives and negatives. And that also means my atomic number is 39 because these numbers mean the same thing. So if I look on the periodic table for 39, where is it? 39 right here. It is Y. So you can go ahead and write that Y in. And then in order to get my neutrons, I have to do my mass minus my protons. So 89 minus 39 gives me 50. So in this particular isotope, I have 50 neutrons. All right, the last one gives you atomic number and neutrons. So if my atomic number is 29, I can look on the periodic table for number 29, and I can see it's copper, Cu. So you can go ahead and write that in Cu. And my atomic number is my number of protons. It is also my number of electrons in a neutral atom. And I know that in order to get my mass, I have to add up protons plus neutrons. So 29 plus 35 equals 64. So that's pretty much all for 1B, you guys. Let me know if you have any questions.